Standing waves. The difference between standing waves and regular waves, as you know them, is that standing waves do not have an entire spectrum of frequencies. The frequencies need to abide by certain conditions, and these conditions are different for the different types of mediums or objects that the standing waves are set up in. There are three main types of objects that standing waves can be set up in. We'll be looking at the type of object with one closed end and one open end, similar to a test tube. Easiest way to remember it is at the closed end there must be a node that is no oscillation at all, whereas at the open end there must be an antinode, which is maximum oscillation. And to figure out how many wavelengths are present inside the object, the easiest way is just to consider a regular sine wave. So if we want to find the lowest frequency or the fundamental frequency for a standing wave inside our test tube, we need to figure out what is the lowest number of wavelengths that can actually fit inside our test tube. And to figure that out, we simply just start at the region where there's no oscillation, and we finish at the first region where there's maximum oscillation. So what does that look like on our regular sine graph? So we start right at the very beginning, that's our first region of no oscillation, and then we go to our first region of maximum oscillation. When you have a look at the number of wavelengths between it, there's only 1/4 of a wavelength. That is our first solution. If we then wanted to figure out what is the second lowest frequency set up in our little test tube, we would go to the next time there's maximum oscillation, which is an additional half a wavelength. So our first solution is 1/4 of a wavelength. Our second solution is 1/4 plus a half, or 3/4 of a wavelength. And then it's just half a wavelength more every time. So it would be 5/4, 7/4, 9/4 respectively. So if we needed to figure out the frequencies of sound waves that would set up standing waves inside my test tube, I need to know the dimensions of my test tube. Most specifically, the length. Just note, we ignore something called the end correction. So let's say the length of the tube is 20 centimeters or something like that. I want to figure out the fundamental frequency, and that is when 1/4 of a wavelength fits in those 20 centimeters. So the longest wavelength set up is 80 centimeters. To figure out the frequency, we just use the universal wave equation and the known speed of sound in air. So in order to set up a standing wave inside our little test tube, the lowest frequency sound that I can use to set up the standing wave is 425 Hertz. And it must be exactly 425 Hertz, at least for year 11. Once you have the fundamental frequency, it's really easy to figure out the other frequencies that can be set up as standing waves inside our test tube. And it's just recognizing the number of wavelengths required goes up by a factor of 3, 5, 7, and 9. And therefore the frequency also goes up by a factor of 3, 5, 7, and 9. So the second lowest frequency that can be set up inside my little test tube is 3 times this. And the third one is 5 times this. 7 times this, 9 times this. So the second lowest frequency that can be set up in our little test tube is 3 times this value. And the third lowest frequency is 5 times the fundamental frequency. Do keep in mind, although it is the second and the third lowest frequencies, it's actually the third and the fifth harmonic, because it is 3 times the fundamental and 5 times the fundamental. Easy peasy, extra marks for you.